Hi, I'm Mark Feldman, Senior Staff Engineer Manager at Qualcomm Technologies. Today I want to talk to you about validation layers in Vulkan. Vulkan is a new graphics and compute API that is standardized and released by the Kronos Group, an industry consortium of which Qualcomm is a promoter member. In the most basic sense, Vulkan layers provide a mechanism to enhance the Vulkan API. This enhancement allows for additional functionality to be optionally added to Vulkan programs. Layers, as the name implies, are a series of layered libraries that get loaded and hook Vulkan API entry points. Layers are chained together. Each layer performs various activities before handing off to the next layer. The most common use for layers is for validation of the API usage, which we'll focus on in this talk. Also, this talk is based on the Vulkan layer usage starting in Android N. There's a set of layers called the validation layers that serve the purpose of detecting errors in your code. Using these layers to validate your use of Vulkan is strictly optional, but highly recommended while in a development mode. For Android, these layers are developed by LunarG and Google, but owned by Kronos. The term standard validation layers refers to these validation layers organized in a specific order. There are other layers more than the validation layers. Some that could be beneficial during the development process for debugging, profiling, logging all API calls, screenshots, trace and replay, and third-party tools. There are likely more to come. Validation layers will be the key way you'll check for coding mistakes using Vulkan. They make sure you don't break the many Vulkan syntax and usage rules. Comprehensive parameter checking is one example of such validation. In OpenGL, you had GL error for detecting problems. Vulkan is a lightweight, minimal API without this feature built in. Validation layers, which you could add to Vulkan, make for a far more powerful tool. These layers provide for an elegant, robust API validation in your application, not in the Vulkan drivers. Validation layer is flexible. There are different layers that check for various aspects of the Vulkan API: parameter checking, threading, lifetime usage, etc. You can load only the layers you want to. You can and should turn off unnecessary layers in production code. There's no performance impact when they aren't being used. They are configurable as well, from the severity of errors they report to how they report or log the errors found. Validation layers are standardized and work the same cross-platform. If you're developing Vulkan on Android, Windows, or Linux, the same error detection logic will be used in the layers. You can expand upon these layers by writing your own if you need to, or do specific checking beyond the layers. And the validation layers are open source, so you can easily look under the covers and see their logic. When your application uses Vulkan, it talks to a system component called the Vulkan loader. The Vulkan loader handles the discovery of layers. It will inspect your application's APK and other file system locations and determine which layers could potentially be loaded. You can ask for a list of potential layers with the VK Enumerate Instant Layer Properties API. It's a good practice to verify that the layers you'll be using have been detected by the loader and are ready to use. When you create your instance using the VK Create Instance API, you'll pass in a list of layers that you would like to use. The loader has the task of configuring the layers in a call chain such that the layers properly process your application's Vulkan API calls in the correct order, with the last one calling the driver. Each layer can contain definitions for one or more of the API entry points and intercept the entry points for which it contains definitions. When a layer does not define an entry point, the system passes the entry point onto the next layer. Ultimately, an entry point not defined in any layer reaches the driver, the base level, unprocessed. Keep in mind that although Vulkan is a cross-platform API, the mechanics of the loader differ between Android, Windows, and Linux. There are a number of differences you'll find on Android than Windows and Linux. There's no VK layer LunarG standard validation. On other systems, this is a meta layer which actually invokes all the other validation layers. There are no registration keys or environmental variables or JSON files used to locate layers on the file system. Note that on Android there is an additional file system location where a debuggable application can enumerate in layers from, data local Vulkan debug, but this requires a rooted device. No user layers that are specified in environmental variables. No implicit layers that are automatically loaded. Implicit layers are detected by the OS and automatically loaded, but this is not supported on Android. On Android, layer source and binaries are included with the Android NDK v12 and later. You can find the source for the validation layers in the NDK at Bundles, Sources, Third-Party Vulkan Source Layers. You can find the pre-built libraries in the NDK Bundle, Sources, Third-Party Vulkan Source, Build Android, JNI Labs. Importantly, on Android, you'll generally need to include the validation layers in your APK. They won't be found anywhere else on the file system. Also on Android, you could set a system property with ADB shell set property debug Vulkan layers, followed by the name of the layers to load. There are 7 layers that comprise the validation set on Android. Threading, which covers thread safety. It checks that objects are not violating threading restrictions. Make sure that they're being called from the correct thread. Parameter validation, API parameter validation, valid usage, validity, obeying device limits, and more. Checking the values of parameters against the specification. Object tracker validates objects for correctness and proper creation and lifetime, useful detecting memory and resource leaks, like trying to access an object after it's been deleted. Image validates items related to the image generation and usage. Core validation. This is the main layer for validation and covers a number of detailed areas, including the draw state, shader checker, memory tracker, device limits. Swap chain validates swap chain related API calls. Unique objects remaps the object handles to enforce that they are unique. Unlike other operating systems which use a meta standard validation layer keyword, the VK layer LunarG standard validation, on Android, the placement order must be explicitly enabled when requesting layers. Layer ordering requires that the threading validation is first at the top of the chain, the first one right after the application makes the API call, and unique objects is the last one at the bottom, right before the driver has passed the API call. The other layers are roughly put in an early to late order. For best results, use this order, which is recommended by Google. Ordering is important because of an increasing set of assumptions when doing validation. Checking for valid parameters should be done first before more involved checks are performed, since latter layers assume parameters are correct. If focused on performance while still debugging, for low overhead, at a minimum, keep VK layer LunarG parameter validation. For detecting memory leaks, at a minimum, keep VK layer LunarG object tracker. Here's an overview of the steps to include the validation layers in your app. First, make sure the layers are included in your APK. With Android Studio and Gradle, you can use the following snippet to include the layers. Note that developing on Windows, this snippet requires that the Android_NDK environmental variable be set to point to the NDK bundle folder in the Android SDK. Next, define a list of the validation layers you'll be requesting. As mentioned in the previous slide, order is important. Then make sure these layers are available. You'll use the VK enumerate instant layer properties twice, once to get the number of layers so you can properly allocate memory, and then again to get the actual layer names. Once you have the list of found layers, search through it and verify that the validation layers you're requesting are included. Make sure the debug report extension is available. Similar to how you got the layers, you'll use VK enumerate instant extension properties twice. Once to get the number of extensions so you can allocate memory, and then again to get the extension names. You'll then verify that the VK extension debug report extension is available by searching for it in the list of extension names. Then you'll create the instance with both the validation layers and debug report extension are specified. When you create the instance, check the logcat to make sure that the layers have been detected and loaded. Then create the validation callback. You'll need to get pointers for the create, destroy, and message functions using the VK get instant proc address, now that the debug report extension is available. The callback function we've defined is debug report callback. Also note that all of the reporting flags are set. You might consider turning off the information bit if reporting gets too spammy. Then create the callback function. This function gets called every time one of the validation layers has something to say. It's up to you to decide what to do with that information. You'll most likely be concerned about the reporting level of the message: information, warning, performance warning, error, or debug. In this example, we use Android_log_print to format a message and send it to the Android log. Notice that the message flag is a bit field, so that messages could be a combination of the 5 reporting levels. In the development phase, you might find it useful to set a breakpoint for the VK debug report warning bit extent and the VK debug report error bit extent when these are reported, so you can see the state of the program and the function call that caused the error. Both warnings and errors are worth your time to investigate. Also, take note that the callback function returns a Boolean that is returned to the layer. Returning true tells the layer to stop. Returning false tells the layer to continue its reporting. And then at teardown, don't forget to destroy the callback function using the function pointer you got earlier. A few tips when using the validation layers. Make sure that the layer libraries are packaged in your APK. Use the Gradle command snippet shown earlier. To verify you have included them, you can use the jar utility to list them out. There's a layer settings file that you can use to configure per layer report settings. You can adjust whether to use the callbacks or just log messages, the name of the log file, and the reporting level. Make sure to push out the file to your device's SD card. Tackle the validation layers when they are first reported. Errors can cascade to cause further validation failures, so again, address each one at first reporting. An application enabled for debug can enumerate and enable layers that are located in Data Local Vulkan Debug. This might be handy if you're not able to embed the libraries in your APK, or perhaps want to use more current ones or even your own. You might find it useful to take a look at the validation source code for a deeper understanding of the reported problem and to see the logic being used to detect it. You can find the code in the NDK bundle. The validation logic is still being developed. Not all areas of Vulkan are equally being checked. Also, some of the logic needs fine-tuning. Our advice is to pay attention to the validations, but realize they aren't always correct. Feel free to ignore them after some research if you're convinced they aren't appropriate. You might also check the Kronos site for the latest version of the validation layers. One strategy might be to explicitly ignore the messages in your callback function with appropriate comments so that you could still be validation clean. That is, run with validation enabled, but without triggering any errors. You might also run into references to Vulkan device layers. These are now depreciated as of Vulkan 1.0.26. All layers in Vulkan are now considered instant layers. Google has a good reference page for setting up validation layers in Android. Kronos has a GitHub with current version of the validation layers. There's also a good write-up on how the loader and layers work on all operating systems. This tutorial provides an overview of Vulkan's validation layers. Now you've seen what the Vulkan validation layers are, how to enable them in your Vulkan application, how to set up a callback to capture, log, and debug the messages, and how to research the reported warning and error messages. Thank you for watching. We hope you enjoyed this video. Please visit the Qualcomm Developer Network to learn more about graphics and tools on Qualcomm's mobile hardware.